with the lending protocol, I think it's just so foundational to a lot of finance, to a lot of, especially institutional finance, that it's just worth doing natively. It's just what makes, I think it's just what makes sense right now to build it natively. And I think just because it's so foundational, like that it makes sense to have that be natively, especially because if institutions want to come to the XRPL, native is a lot easier for them to trust because smart contract code or something like that tends to get a bad rep or, is a little harder to trust. So smart extensions I think they're a very XRPL way to look at programmability, which is essentially you take our powerful primitives that we all know and love and we already have, and we can add a little bit of programmability on top of that to add some customization ability.
Hey, and welcome everyone to Krippenreiter TV, our weekly series on Monday, hosted by me, Krippenreiter, and my regular co-host Ved. Today we are joined by Mayukha Vadari, staff software engineer at RippleX. She's very well known in the XRP community for expertise and work on RippleD as an XRPL core developer and her work on developer tooling, namely XRPL Pi and XRPL.js. Prior to working on the programmability efforts around smart contracts and smart escrow, she worked on XRPL interoperability, better known as Exchange Bridge. She's also CEO and founder of Grism, aka Girls Rock in Science and Math. With her help, we will hopefully all learn something new about XRPL today and where XRPL is headed in the future. Hey, you two. I hope you're doing well today.
Yeah, I am.
Doing fantastic.
Awesome.
It's great to have Mayukha.
Thanks for having me.
Hope you're doing well, Mayukha.
Yeah.
Awesome.
I'm honored to be the first guest on your show.
Actually, yeah.
Actually, that's true.
It's the first guest, yeah.
Okay, guys. Yeah. Before we jump into the topics and speak about smart contracts and smart extension and everything, maybe Mayukha, tell us about yourself. Tell us about what brought you to the XRP Ledger and what brought you to RippleX especially.
Yeah, so I actually did not really have any blockchain experience before I joined Ripple. It was the only experience I had was I took an applied cryptography class in college, and one of the assignments was to essentially write a basic proof of work algorithm. That was about the only expertise I had with crypto. I had never even heard of the XRP Ledger. Didn't really know much about crypto. I joined Ripple out of college, so I actually talked to some folks at RippleX at my college's career fair and just had really good conversations. And, I didn't have a lot of specific requirements when I was looking for where I wanted to work, but it was really just, I want to work on cool stuff with cool people. And that's vague, but also, when you see it. And definitely hit the mark here at RippleX and in the XRP Ledger community.
I think you cannot even beat that with the XRP community and just in crypto in general. Like you get everything.
Yeah.
Everything in between.
Never a dull day.
100%.
That's true. Not only on Ripple, probably also on social media as well. There's a combination of craziness that is happening in the community and in the ecosystem every day.
Yeah. I remember when I graduated, I was worried that, in college you change what you do every semester. I was worried that when I graduated and started working and I'd have to work on the same thing for 2 years or whatever, I'd get bored for working on the same thing for so long. But I think crypto and the XRP ecosystem have all just been changing so rapidly that you don't have time to get bored.
True. Talking about changes, RippleD, aka XRP Ledger D in the future, version 3.0 dropped on Tuesday. From all the changes that happened, I think I have counted 98 changes actually. What's your highlight and why was a major upgrade even necessary?
The major upgrade is because the lending protocol is being pre-released, I believe. So that's probably the highlight from this particular release is the pre-release of the lending protocol. Basically, what that allows you to do is test out the lending protocol in standalone mode or local testnets or something like that.
I would wonder why the lending protocol especially needs to be on the layer 1, especially this one, because AMM And in conjunction with the CLOB, I get the idea behind it and why it should be on layer 1 and not a smart contract, or maybe both, but more so on layer 1. But the lending protocol especially, I don't really understand why it should be layer 1 based.
So I actually had the same question as you. I was also a little bit unsure about that. Like AMM, you have the integration with the CLOB and the DEX, and so it makes sense, and you get a lot of benefit from it being native. With the lending protocol, I think it's just so foundational to a lot of finance, to a lot of especially institutional finance, that it's just worth doing natively. And it's also, in the current state of the XRPL, very difficult to do it any other way. So it's just what makes, I think it's just what makes sense right now to build it natively. And I think just because it's so foundational, like that, it makes sense to have that be natively. And especially because if institutions want to come to the XRPL, native is a lot easier for them to trust, because smart contract code or something like that tends to get a bad rep, or is a little harder to trust. So native is beneficial from that respect.
Yeah, I would also add that you get this like shipped in with RippleD basically, or XRPLD. That is also major. Like you don't need to code this from scratch. I love to bring like this example of in the hackathon, Paris Blockchain Week. A lot of people chose actually more to build on the XRP Ledger than on Solana there. And the reason was because of interesting technology, but because they could also immediately work and not like code first the smart contract and then deploy, and then you have the token, right? They can immediately just go to executing their idea, which is amazing. And the lending protocol would be included, because lending protocol means it's also more than, there's a lot of parts in between. For example, XLS65, which is the single asset vault.
Yeah.
That alone, in my opinion, is like super valuable to have as an on-chain object natively to be used. So yeah, I can see.
I can imagine you can put the single asset vault and the CLOB and the AMM, because all these are like not the CLOB, but in some sense they are like pools where you put money and liquidity in. And I can see when this is all put on layer 1, how this could be added in some sense and linked to each other to share liquidity in some clever way that is easier to do if it's native than if it's based on a smart contract.
Yeah, and that brings up another valuable argument of of why it's beneficial to often have things at the native layer, which is how features interact. You can essentially have multiple features all interact with each other, but you can only do that if they're native. If they're smart contracts, it's a little more complicated. It's going to be less automatic, less atomic.
And plus, if you, let's say, even with XS 101, I think even in the first release, you cannot have like contract calling another contract, which you would need to do if you don't have them as native object. If you have it as native object, you can just have call native objects essentially.
And even then, you can have, even if you could have contracts calling other contracts, you're still it's not going to be as automatic and sort of built in with each other as it would be if it was at the native layer, because you don't need to have that like transaction that calls another contract essentially in the loop, which breaks some like atomicness in there.
Plus, this comes typically later, I think, with developers because they try then to optimize for low cost, like constructing programmability, so that I guess even from a transaction fee point of view, it would be cheaper, right? Like if you call a native object, then if you would call, let's say, a contract that would execute and has like this custom logic. So if you want to save on transaction fees, it might be also more beneficial to use more native objects.
Yeah, emphasis on might, because you may want for some of the more complex operations, you may still want higher transaction fees even for native features.
There are many fee levels anyway, right? We have drops right now, and later with the introduction of WASM VM, we also get gas costs, which is like compute.
Yeah.
And if I understood it right, 1 million drops is 1 XRP and 1 million gas is 1 drop, right? This is like the calculation, right?
No, actually.
I think no,
Essentially, the gas price will be modifiable by the UNL, like the conversion between gas and drops. So it's just measured in like millionths of a drop, because it'd be kind of annoying and very expensive if one gas cost one drop and you couldn't go below that because of just units. So just to make that easier, we said, okay, let's make the units that we measure this exchange rate in like micro drops, or 1 millionth of a drop, because then you can, for example, what we have on the testnet, on the devnet, is we have gas at one gas is 1/1000th of a drop, so you get 1,000 gas in one drop.
That's super interesting because that means, so just theoretically, because I was thinking, hey, even for normal transaction fees, it's votable, right? Let's say 10 drops, but you could, of course, lower this, right? Let's say to 1 drop even. But you couldn't go below, right? This is like sort of the hard limit, 1 drop. That's like the atomic, the last value, basically.
Yeah.
But with this, you can go even below if necessary. Okay.
Yeah. I think a lot of the test smart escrows we have are on the order of a few hundred gas, or maybe in the low thousands. So that'd be rather expensive if you couldn't go below 1 gas per drop.
Usually when we talk about smart contracts and gas costs, it's mostly the other way around, that gas costs are huge, and this is a concern for many blockchains. I wonder if with the on XRPL, I wonder if the introduction of gas costs and wasn't VM will burn maybe too many XRP. Is there any, like, is this being worked on, like that burning too many XRP could shrink the supply too much? Because this was a concern that the Zahao people had, which is why they introduced this mechanic to inflate a little bit and then get the balance adjustments, right?
Yeah, I'm not an expert on Zahao, so I don't want to, put words in their mouth, but I'll do my best to explain. If I remember correctly, I believe the way gas, the equivalent of gas and hooks work, is it's basically set at 1 drop per gas. So it does get rather expensive very quickly as a result. We also have both hooks and smart escrows, XLS 100, have this concept of host functions, which you can basically think of as like an API to access information from your WebAssembly code about, RippleD, or just fetch information about the ledger, like what are the fields of this ledger object, what are the values of this field, type of thing.
And that does not come at gas cost, right?
There is an extra gas cost for host functions. There's a specific cost for each host function. They're all listed in XLS 102 if folks are interested. So I think that's sort of one key difference, is like those are, I believe, free, or maybe 1 gas on for hooks, and so I think that results in slightly different economic models for how gas operates on the two designs. But I think to some extent we have to see, what is the usage of this? How high are the gas costs for the WASM programs people write? And then, I think to some extent we can cross that bridge when we get to it. I don't think that's going to happen. I don't think we're going to burn some massive amount of XRP in the span of months or anything. So, yeah.
Okay. Are there any estimations, like in the future, like in one year, let's say we have 1,000 smart contracts or WASM VM-based smart escrows running? Are there any estimations how much XRP we are burning? Like not specific amounts, but are we talking very high amounts?
I don't think it's very high. I wouldn't say it's negligible, but it's like probably mostly on the order of a few drops per transaction.
Yeah. Okay. Plus, I would say, in general, also transaction fees is like sort of a function of network capacity. And so it's like what you want to allow basically on the network. If you say, hey, we have more capacity or more throughput, then you can lower the fees, right? You don't need to keep them artificially high, for example.
And you have a lot of metrics
Yeah.
you can mess with even on the WASM side. You like from the UNL's perspective, at least the UNL can
Yep.
adjust maximum code size that you can deploy to the XRPL, maximum
Nice.
compute size, which is essentially what's the maximum amount of gas you can run in one transaction, and you can mess with gas price. So those are the three metrics you have. So if you feel like XRP is being burned too much, maybe you can reduce the gas price, or you can reduce the max gas amount, the compute limit. So you've got some things you can play with on that front.
So, Mayukha, you basically jumped already into this. Maybe we can walk through, because you said smart escrows we talked about, and we touched also smart contracts. This is like all this programmability effort that you and your team are working on, right, at RippleX. And you started with this idea first, okay, programmability, we want to approach this in baby steps. And one of those should be still very useful. And then you came up with something called smart extensions. Maybe you want to talk about these smart extensions and sort of smart escrow as a part of this.
Yeah. So smart extensions I think they're a very XRPL way to look at programmability, which is essentially you take our powerful primitives that we all know and love and we already have, and we can add a little bit of programmability on top of that to add some customization ability. Currently, the native features are super useful, super powerful, but if you wanted, and you can do, a lot of things with just the native features, but sometimes there's some little bit that the native features don't quite do what you want them to do, and as a result, you're sort of you have to figure out some way to work around that. Now this smart extension idea makes that a little easier. There's going to be certain touch points where you can actually add your own customization in the form of WebAssembly code to cover that gap.
And smart escrows is sort of in a case of this, right? Because
Yes.
that's a native object on the ledger, right?
Yeah.
That has a WASM module, let's put it that way, attached to it. What is sort of then smart escrow? Is this basically then an escrow that is supercharged with WASM, basically?
Sort of.
Say that?
Yeah, so you can think of an escrow as a pool of one asset that is essentially locked away, and it has one destination and one origin point, and it's released in like an all or nothing situation. And there's two ways that it can be released. One is time based. After a certain amount of time, you can release those funds. This is how Ripple's escrows operate. The other is using what's called crypto conditions. I won't get too much into that right now, but we can essentially explain that as you need a password to unlock the escrow. And if you have that password, then you can unlock it whenever. So one thing that this password unlock enables is essentially like off-chain smart contracts. So the example that's listed in the xrpl.org docs is like you have some vendor for your kid's birthday party that you need to pay, but you don't want to pay them before the party in case they screw up or don't show up or something. So instead, and they also need the guarantee that you're going to pay them. So instead, you can have a third party and they can set up this password situation, and then you can you can put the funds that you owe the birthday party vendor into the escrow. And then once the vendor shows up, the third party can provide the password and release the escrow.
This already kind of sounds pretty customizable, I would say. So the difference between like the password-based lock and the WASM-based lock is really that with WASM, you get even more than this. Like probably you can do basically most of what you want with the password off-chain stuff, and then you have time lock as well. But in case you really want to be on-chain all the time and want to be really customizable with your finish function, this is where WASM like the WASM module starts to interact with Escrow, right?
So the difficulty with off-chain this off-chain smart contracts is you're limited in you have to build a lot of infrastructure often to maintain such a use case. You have to and if you're just using on-chain data, that feels a little overkill sometimes. So what this allows you to do is it just integrates it directly on chain, so you don't need that complexity of all this off-chain infrastructure to manage all that. You don't need a server that's constantly listening to the XRPL, determines when this condition is true, and then submits the password. That server also doesn't need to store the password for who knows how long and all of that. So it's just a little easier to work with is what it is.
Would the WASM VM escrow cannibalize the password-based off-chain escrow? Because I can think you can do the same on-chain and just get rid of the password-based escrow.
I mean, I think there's still a lot of use cases for the password-based escrow because you can't do everything on-chain, like the birthday party example, right? Like if your vendor isn't doing everything on-chain, then you still need off-chain data. So maybe this is the best way to do that. Yeah, you could also potentially do so in an Oracle manner and have the smart escrow check for the Oracle status, but maybe it's easier to do it off chain as a result.
This is something that I really like about the WASM module in Smart Escrows. It allows you basically to fetch on-chain data or check accounts that interact with this escrow and either evaluate to true or false. For example, do you own a specific NFT, right, or a token or something like this from an issuer? If yes, then I evaluate to true, else false. Or you mentioned the Oracle. Where you can basically see, let's say, an XRP price. If the price of that specific Oracle says so and so and so, right? Release, else no.
Yeah, if you don't trust yourself to not panic sell, you can always put your funds in a smart escrow that will not let you release until the price of XRP is at a certain value.
But I do know people actually who have their funds escrowed. Very, very good people. High conviction. That's good.
For many years, 10 years.
For many years, yeah.
Oh no.
so far into the future that they are chill.
That's conviction. I mean,
yeah.
I mean, the XRPL will not ever go away, I would say, just like any other blockchain, just because of the way it's structured. So many validators, so many nodes. The community is just gigantic. So you could play the game of waiting 10 years or longer, and you will probably get your funds back. I don't see why you shouldn't. But then again, who knows about the price, right?
But this is the cool thing with why you guys chose the escrow to introduce this functionality. This was, like, for me, really great to hear, because when you evaluated which object to get, there is sort of like a way to say, okay, if I made a mistake, I can cancel it at least after some time. That was very interesting. Can you maybe explain that? How you?
Yeah. So the main criteria when we were thinking about, okay, how do we take this paradigm and actually make it something that is useful is, one is, okay, is this going to be like a limited use case? If something goes wrong, like it's not going to affect like a lot of people. Another is like, is it actually useful? And so this concept of like off-chain smart contracts with escrows and the password locks sort of shows that even just bringing that on-chain does have a lot of utility in there. So that checks off that one. And in terms of like limited effects, we didn't want to mess with things like accounts or tokens, at least at first, because if something goes wrong, that gets pretty difficult to work with. Even if that's just somebody screws up their WASM code, makes a mistake, there's some bug that makes this like that like bricks this escrow, that's fine, because anything that has any smart escrow must be cancelable. So after a certain period of time, this escrow can be canceled. So even if it's 10 years from now, you will be able to get your money back if something went wrong with your WebAssembly.
That's amazing. That's really cool.
That's great. About the use cases as well, I remember in your explainer that you wrote about Smart Escrow and the initiative. You wrote just at the end, there was this one use case where you said trustless token swaps, delivery versus payments. And I remember Luke Judges from Ripple, he said that this is something the institutionals want, because they want to like escrow tokens on both sides and want to assure that if the payment happens, it happens under a condition where both sides know for a fact that they will get their money and don't get screwed over some weird circumstances.
Yeah.
How did you call that?
It's called trustless token swaps, delivery versus payments. This is how it was called in the explainer.
Yeah, it's sort of two different concepts. Trustless token swaps is, I guess, the way that this is implemented, and delivery versus payment, or DVP, is essentially a very common use case or thing that people need to do. It's essentially, when you pay somebody, when you provide a service or a good to somebody, they want to get paid. So, for example, you might have like some sort of digital assets, or like a stock or RWA or something on one side of the token swap, and on the other side is going to be like maybe a stable coin or something to pay for that, whatever it is that's the RWA or whatever.
When you said trustless token swap, I was like, never say trustless with Mayukha. No.
It's not a concept.
No.
It's not that I object to the word trustless in general. It's just, so if you're operating on one blockchain, you are trusting that blockchain. If you are operating between two blockchains, I, as a user of one of those blockchains, don't necessarily trust the other blockchain. So there's always some level of trust when you're going between chains.
Right.
That doesn't necessarily apply when you're existing on one chain. So it's a little bit of a different situation there.
David wrote a very good piece on governance, where he said, like, you need to trust sort of the other governance of the other chain.
Yeah,
like maybe
exactly.
You don't want to trust them, and they don't trust you. So how do you fix this situation where both are? It's actually it's not so trivial, honestly. Once you really go into the depth of it, it's not so.
And it gets more complicated the more steps you add.
Yeah.
Like, for example, when I look at Strobo protocol, for example, you see the XRPL, and then you see XLR, and then you see the XRPL EVM sidechain. And in between, you have this general message passing going on. And there are so many like building blocks that work together. And you can see that this is working. But in my mind, I'm always checking how many steps I'm trusting right now.
Yeah.
Am I trusting too many steps? Shouldn't this be easier? Shouldn't this be more trust minimized? Why do we need to trust so many smart contracts and blockchains in between, when this could easily be happening on XRPL natively, right?
Yeah, I mean, that's the difficulty with bridges. It's complicated. It's hard.
Yeah. Mayukha, so you guys did a ton of research, specifically you ahead. I know for a lot of people, this whole discussion about programmability and smart contract is sort of, maybe it's like coming up, or no, it's very new, but you guys did actually a ton of work like over a year ago, and you were posting very actively about the progress of it and report, and you took basically the whole community with you. I want to commend you on that. It was really great.
Thank you.
And you guys did research on the virtual machines, where you compared it to multiple other chains. And sort of, programmability in smart contracts is not equal programmability in smart contracts. They differ, and also the approach how you do it.
Yeah.
Do you mind like maybe touch on the approach that you guys took for the XRP Ledger? Some of the things that was important for you when you choose, like, okay, the certain things like the virtual machine, how it interacts with RippleD, and so on. Maybe you can walk through that research thought process. I think that would be helpful for a lot of folks.
Yeah. Some of the important points were, does this mesh with how the XRPL currently works? We don't want to get rid of the native features. We don't want to like rebuild the XRPL or switch to another chain or something like that. So how do we build something that actually benefits the XRPL community, the builders and the institutions and basically all of the different stakeholders that exist? and how do we make it so that it's going to be safe, that it's going to be easy to use, that it makes sense for people coming from other ecosystems, that it's using like design paradigms and all of that they're used to. So a lot of things just didn't really make much sense or didn't really have much adoption. So we discovered that pretty quickly. We went into like 10 or 12 different options that were all evaluated. Yeah, so like permissionless, native feature access, ease of learning. Uh, Also, another important thing is how easy would it be to actually integrate into RippleD? So something that is Rust based is a little more complicated than something that is C or C++ based, for example. And then there's also some level of ecosystem adoption that's important. Uh, like, do other people use it? If not, like, is there something else that makes it worth for us to use? And so we narrowed it
Yeah, very good.
down based on that analysis to like WASM, like Aptos style move and EVM. And then we did a deeper dive on those three and discovered that EVM didn't really work because like one of the major benefits of EVM is everybody uses it, right? But if we wanted EVM to come to the XRPL and not just need to rewrite all the native primitives, the smart contracts, and all of that, because that sort of defeats the purpose of having them at the native level, um, you wouldn't really be able to get those benefits, because you'd have to fork all the tooling, you'd have to modify all the tools. So you wouldn't really be able to copy paste a smart contract in the same way, which is, I think, one of the biggest benefits of EVM. So if there's no point if you can't do it that way, then what's the point, basically?
Right.
And Move, we did another analysis. It's essentially got a similar thing to RippleD, where everything's all very integrated with each other. So it's hard to extract just the Move VM from the Aptos code base itself. And that was just something that was a little too difficult for our ability to determine. Yes, so it was harder to tell like what we would need to extract, what we could leave in Aptos, and all of that. So just rather complicated. So that leaves us with WASM, and I think it was a good decision.
Yeah.
I like WebAssembly. It's got a lot of flexibility. You can write WASM code in just about any language. Most languages have at least basic support. Though it may be a little, you may not be able to use all of the features of that language, just because of how WebAssembly works. Did I cover all parts of your question?
Yeah, absolutely. No, that's fantastic because it just shows when you go into that report, and I'm pretty sure we can link this also then in the comments, but it's very in depth, and it just shows that there's a lot out there, and you cannot really go just by how things are really called, but because under the hood they massively differ. And I like the approach that you
Absolutely.
guys took for the XRP Ledger to see, hey, what actually do we want to achieve? And we want to elevate the things that we have, but introduce also sort of this business logic that we can do to a degree to connect these primitives that we have.
Yep, absolutely. I mean, that's definitely a primary goal of programmability is, as you said, the glue between the various primitives. We have these primitives, and just being able to knit them together more easily, more seamlessly with a touch of programmability adds, exponentially more value than just having the primitives and knitting them together off chain.
Yeah, and we just talked, when Krippenreiter was mentioning like the trustless swaps and things like that. It's not necessarily like always when we think about trustless or something like this, but on the XRP Ledger, everybody who's like basically building is very familiar that you need to do a lot of things off chain,
Yeah.
and to have these things like on chain or bring them on chain is sometimes better because you can see it. So you can see at
Yeah.
least what do you deal with, because if I build a project and you interact with it, you sign it with someone. You need to trust that whatever I built in the backend is continuously proposing transactions on the ledger or not, and what it does. But if it's on chain, that's actually kind of helps it. And plus, you could actually even have multiple front ends interacting with the same, let's say, contract. That's actually also something very interesting. But that's just a side.
What I would like to learn more about is ABI, because this is one key difference that is different on EVM than on WASM VM, the way XLS 101 will implement it. It's in the end, because it's different, it's more human readable, right, Mayukha? Maybe you can touch on this and how it works.
Yeah, so the XRPL, one thing I really like about it is the transactions are human readable, which is not true on the EVM. It's all just hex. There's no like JSON representation. You have to have tooling to decode that hex into something human readable, which is what the explorers do, for example. And I just really like that I can get information directly from RippleD that is completely human readable, and I know exactly what it's doing. That's not really possible for like WebAssembly code necessarily, but we can do that with sort of all the things around it. So ABI is one aspect of that. So you can essentially keep on chain, like what are the function names, what are the parameters they take, what are all the different flags and everything that you need, all of that. And I think that just makes it a touch easier to read, easier to work with, a little more easier to understand. Plus, you get to be able to do those checks before you even open the VM. Like, are you providing the right parameters? Are you calling a function that exists? And you save a little bit of time and energy without even needing to open up the VM and run that WASM code. You can just determine if that code is even valid in the first place, or if that contract call is even valid in the first place.
This secures the user as well, right? Because there you can force certain like guardrails. You can guard the user before he's doing something that he probably shouldn't do. This is one aspect I think that is pretty different, because one aspect of smart contracts in general or programmability is always security. Like how secure are you on the XRPL or on Ethereum when you interact with something smart? Like, let's say I'm completely against programmability altogether. Maybe I'm so scared about the security aspect that I will probably maybe decide to never interact with it. On this, maybe, is there any misconception that you think is particularly true to smart escrows and extensions that you maybe want to clear up?
I think it's a limited scope. It's not going to overrun the ledger. We're doing a lot of heavy, performance and security tests to ensure that that's the case. And we're also, there's all these guardrails that exist for this. You have UNL votable compute size or compute limits, size limits. You can adjust the price. So you have all of these configurable things that make it easy to limit what's happening on an ongoing basis, depending on how it's impacting the ledger. So you can do so pretty safely, in my opinion, and introduce smart extensions, smart escrows in a way that is safe for the network, where you can trust that if you're not planning on using smart escrows, you'll still be able to do what you want.
That is actually very important, because that applies also to smart contracts, of course. If you don't want to interact with them, you can just not do so. You can just use your normal objects just fine. Everybody will flag it to you if you are about to use something that is sort of WASM enabled. Let's put it that way.
Yeah.
And they just then don't do it. Yeah.
With this, I was thinking about the user that is not like well versed with WASM and coding in general, but in the end he still wants to use some kind of WASM capabilities. Would there be any way for someone who just doesn't know how to code? Would there be a way for them to use WASM supercharged escrows in a way that is easy? do you think there will be interfaces or websites that will like provide services to make this easy and human readable and just safe in general to interact?
Yeah, I expect so. I think there's also, potential room to build like no code tools where you just stitch together different pieces of functionality and write something that way. I don't know if you're familiar with the sort of the basic um, programming languages, I guess, that they use for kids to introduce them to programming. Like the one I'm most familiar with is called Scratch. It's from my alma mater, MIT, and essentially it's like a drag and drop of different building blocks, actually. um, Lego bricks and that sort of thing, and you just drag and drop them, and you can make this like little creature move around on a screen and stuff like that. And I think some people have built some fairly complex things just with this like visual interface of coding, no text involved or minimal text involved, and it's a very it doesn't require any coding knowledge. It's intended to help you understand how to think about code from that perspective. So I could very much see somebody coming up with a tool that essentially allows you to do that with smart escrows or any other, smart extensions that may come in the future.
Talking about other smart extensions, right? What
Yeah.
what possible smart extensions are there? I think about smart tokens, maybe smart AMM, please. Some form of better AMM, or in general, just what kind of smart extension do you think makes sense?
The difficulty with smart AMMs is AMMs are so integrated into the CLOB that you don't, just by submitting a transaction on the ledger, trading a trade on the ledger, like you don't know if your transaction is going to hit that particular AMM or not, which means you don't know if you need to pay gas for it, for example. So that's one difficulty with that. And I know you want it. I know other people want it. So I've been trying to figure out if there's a way to make it happen. I haven't come up with one yet, but that doesn't mean it won't happen. Maybe it would be some other AMM that isn't as integrated with the CLOB, or I don't really know. I haven't quite thought that far. Yeah, I think some other potential options may be like you could do like a smart batch where currently you've only got the like 4 flags for how you can how you can sort of mix and match your batch inner transactions to create a successful batch. Maybe you want a little more customization, some sort of complex and or tree or something like that. Smart permission delegation interests me a little bit, where you can delegate. So currently you can delegate permission. That amendment would allow you to delegate certain transaction types or granular permissions, like just authorizing trust lines but not creating trust lines, for example. Things like that. So what this could do is allow you a little more customizability on that. So you can also say like you have access to payments, but you can't ever send more than 100 XRP, or you can only ever send money to these 3 accounts or something like that. I could imagine that being done with some WebAssembly code as well. I think those are sort of the main ideas off the top of my head.
I was thinking about a batch in the early days from the batch design. One decision was to get rid of nested batches.
Yes.
Is there something you could do with WebAssembly batch, like Smart Batch? Could you nest the batch trend, the inner trans? Could you build outer batch transactions inside the inner trans?
Yeah.
You
could
have
essentially
this one wrapper, but yeah.
You could essentially unroll that nested batch into just one batch transaction with some WASM code to handle that nesting. Essentially, I think you could do that. Yeah.
So Mayukha, I'm really into pseudo accounts. Huge fan of pseudo accounts. What would be the thinking of smart accounts? If I think of smart account, I think of 101. For me, that's sort of it, because it's essentially like an account. A pseudo account where you put the WASM thing on it, right? Like instead of on an escrow, or you mentioned AMM, you put it on a full XRP account, a full account root. Not full, but you know what I mean.
Yeah, I would say like a smart pseudo account would be roughly XLS 101. I think a smart account is there's a lot of intriguing ideas in that space for sure, but it's also something that you need to approach very carefully, because if something gets screwed up, then you're potentially bricking somebody's account. So, or if you may also be allowing scammers to potentially install some essentially malware on their account. And so I think smart accounts therefore needs to be approached very carefully, and I think shouldn't be one of the first few extensions that we consider as a result, because let's get people used to the paradigm in slightly more safer use cases first.
That's why I personally don't like the idea of sort of putting it on someone's personal account, but rather, let's say, on a pseudo account which has no signing keys, right? Apparently, like you cannot just sign it. It's stripped away from that ability, which is good, because you don't want people to add it onto their accounts and
like remote desktop, right? You control something remotely instead of directly, right?
Sort of, I guess. You know, with all these programmability approaches, in our conversation, it was very clear when we talked about the use cases and things like that, is the immense value of connecting existing functionalities that we have on the XRP Ledger. I think this is like the huge, powerful tool that we have. I mean, you mentioned the AMM, and then maybe you have like an Oracle that you want to plug into. And I think this connector is like really what makes it for me. Is what is so appealing, because oftentimes when you're at Apex, right, and you talk with people about use cases, it's then you say, oh, what if we connect this and this and this, and then something amazing comes out of it, but you have to realize you cannot do it on chain. There's always an off-chain component to it, which is an opportunity, right, in my opinion, that we are approaching this with smart extensions, which I'm a huge fan of, and the WASM module.
I mean, you can already see
on this,
you can already see features getting knitted together like that with some of these smart escrow use cases, like knitting together escrows and oracles or NFTs or credentials or something like that.
Yeah, and you don't need like a separate amendment for this. I think this is like the powerful thing, because an amendment has just an entry barrier range of entry, right? Because not everybody can code, let's say, in C++. Plus, it goes through scrutiny, because obviously people want to see, hey, it goes review. You need to adopt even the tooling, like libraries you need to change, documentation you need to change. So there's like a huge tail that comes with it. Which makes it just easier for people to get into with something like that. Yeah.
And it takes time as well. Like everything amendment based just takes time. People always think about all these use cases that we can add.
Not for Mayukha. Mayukha is running through this thing.
No, I'm just like, they don't realize that adding anything that is amendment based just will take a lot of time. And if you're a startup, a project building right now, you have to decide if you wait another 2 years to build something, or if you just use something that is existing right now. So for example, let's say you have, and I have this in mind right now, not me personally developing, but I have heard people telling me this. You can use smart contracts, but you have to use them off-chain, XRP Ledger EVM sidechain based. But you could do it on-chain on XRPL, but because it will take basically forever until smart accounts or smart contracts, smart extensions will end up on the XRPL. It may not make sense to actually wait, but build something now off-chain, so you can start in any way. So this is also a fact where I think if we at some point end up with smart features on-chain that are really powerful, I can also see people like switching over. Like they have built their solution somewhere. Maybe it's the XRPL EVM sidechain, maybe even the how, and then they come back to XRPL, or XRPL goes elsewhere and it all gets interconnected because it's now easier with extensions and smart contracts.
Absolutely.
I would think this is powerful.
Yeah, but if you think about it, because I was talking with a Fig from Squid Router, And and we were talking about it. He said like they do it through the EVM sidechain, and so they connect through that. And let's say smart features on the XRPL would not necessarily like eliminate any other like chains in that aspect, but actually make them better. He said like we could do it faster then. He didn't go into details, but it would basically just enhance things, make it just quicker. He said you could do it like in seconds and things like that. And by the way, I want to encourage people also to think about that, because when we think about native functionalities on the XRPL, and I like what David actually mentioned that, but I talked about this also separately. Is that you can only build really front ends on the XRP Ledger and wallets, right? You cannot have like sort of your own financial products on chain that you can have, and you need to treat essentially all objects on a ledger if you want to update them as public goods. So you talk, Krippenreiter, a lot about AMM upgrades, right? If you think about AMM upgrade, you need to think about not what is good for me. You need to think about, okay, this is like a collective good, right? So I need to, everybody needs to come together.
There are many parts. The product, the user, the liquidity provider, you have to think about all these parts. And they're all very complicated. They have all their own issues that you have to think about and find solutions for.
Right. And even like from a voting point of view, you need to make it democratic because it's a public blockchain, right? And we all belong it. But if it's your smart contract, you can say, hey, this is mine. And, my rules, which I think would enable the XRP Ledger DEX to be bootstrapped really, really fast and quick, because you can sort of guard liquidity. And we had like already these examples with MXRP coming to the XRP Ledger, right? And some projects on the XRPL work really hard with XLR to get them over to the XRPL. But once they are on the XRPL, everybody can interact it. You can go to XP Market, First Ledger, Anodos, and so on. But if I did the business development effort, I would love to be available on my protocol first, so that it generates revenue for me, and I can pay my effort, so I can onboard more people instead of it being sort of democratized by immediately. There's like really a lot of interesting concepts.
Mayukha, could you do a smart CLOB, basically? Smart central limit order book? Or is this the same problem that we have with smart AMM? That because it's too integrated with the payment engine, it's just way too complicated?
I think you'd probably have the same issue, but I think it also depends on in what direction are you making it smart. Like, for example, I published an amendment idea a few weeks ago for like a scheduled offer idea, where you can essentially, your offer is just not put on the CLOB until certain conditions are met, which can be, you can have a couple of hard-coded options. And if you want anything more complex, you can have that be like WebAssembly. And then you can sort of unlock that offer where it actually gets moved into the CLOB when those conditions are met. So, that's arguably, I guess that's more of smart offers than smart CLOB. But I'm just saying that there are ways that you can get creative and make things smart without having the limitations that we discussed. But I suspect what you're getting at would be sort of difficult.
Yeah, there's there's like the last question that that's actually
I have one last question that I always have. I have this one weird last question that I think is interesting for people to know. And it's a mix of, like, I will use a word that is coming from the smart contract world. So basically, what keeps you glued to the XRPL and working for RippleX these days? Because you are working for RippleX, I think, for 5 years now already.
Yep.
Why are you still here?
Anniversary. Congrats.
Congrats. Yeah.
My anniversary was 3 months ago, Vet. You're real late.
Oh, okay. Oh, damn. Look.
I mean, I think it's like what I said at the beginning of this chat. It's, never a dull day in crypto, in the XRPL community. There's always interesting stuff to work on. Programmability is a lot of fun and very interesting to work on. So I think it's just, I continue to work with cool people on cool problems. So, why go look for anything else?
So the craziness doesn't shock you.
I would say in the beginning maybe a little bit, but honestly, since ever we talked, actually, Mayukha, you really got accustomed. I remember in the beginning it was like, and now it's like whatever. It's like, yeah, that's community, you know, and
Yeah.
I love to see that. And how you dive into it is really amazing. You do everything correct on that front. Maybe something for people also to know that you actually work on like these two subjects in crypto who I would say are huge, not only research fields, but application, and there's a lot of work like programmability and also interoperability, right? That is
Yeah.
also a field of expertise of yours. Cool. Is right now, are you working exclusively on programmability, or are you also looking something interoperability that you will pursue and do with Ripple and RippleX on the XRPL, or is right now full focus programmability?
Yeah, pretty much exclusively programmability.
Okay.
That's powerful because of programmability. I think you will also at some point lead into zero knowledge proofs, right? Because people are talking about privacy, and then when you talk about privacy, you will end up with WASM, and so yeah, there are connections between these two topics, and both are, I think, equally important. But we have to get programmability right first before we can really dive deep into zero knowledge proofs, because it's also interconnected.
Yeah, I expect the first integration of ZKP on the XRP Ledger will definitely be via programmability, like adding a couple of host functions to make that math a little easier and cost more of a reasonable amount of gas.
Okay. But once you have like these host functions, and by the way, XOS 102 for those interested, as you said, host functions, you can use them or with programmability, right? Like you can tap into them. You can just call a host function. So at the end, we can keep programmability as it is, right? And like with its capabilities. But when we add host functions, it will automatically enable those programmability things that we have on the XRPL to do more things, right?
Yep. Yeah.
Okay.
So you can write a ZKP for as a part of your unlock criteria for your smart escrow, for example. Prove something off chain, zero knowledge wise. If you want to keep your exact unlock criteria a little secret.
By the way, because you mentioned also cryptography a lot, when you guys see this video, so when you see this video tomorrow would be that, is the space with Ayo and head of engineering at RippleX. Everybody's of course welcome to join and talk with, because I know he's heavy into cryptography and privacy. So that's an interesting, that's an interesting spin-off what we can do then on that space.
Yeah, you can ask him all your cryptography questions.
Yeah. So Mayukha, with programmability and like all your efforts as well that you do, what sort of would you wish also from the community and maybe developers, sort of call to action, things like that to test it out, and all of that? What would you encourage people that would help the most, sort of to bring these things to life, but also to give feedback to you guys?
Yeah, I think what would help the most is like you said, test it out, getting involved. There is a UI that you can use to play around with smart escrows, so you don't need any code expertise. I think also just getting a little more knowledgeable about what these paradigms are, what these primitives are. There's a lot of misinformation going on about various aspects of programmability, so just make sure you brush up on. Make sure you understand what's going on, what all these new specs, new ideas really mean. Not necessarily asking you to read and memorize the spec. If you want, you can toss it into AI and ask it all your questions. I'm sure that's what a lot of us do these days. But just make sure you're knowledgeable about what you're talking about when you're having discussions, because it's hard to have a productive discussion if we're not all talking about the same thing and on the same page about what we're talking about.
100%. Education maxing should everybody's priority be.
Absolutely.
With this, thank you too. Thank you, Mayukha. Thank you, Ved. As always, absolutely pleasure to talk to you guys. And maybe in the future we will do it again when Smart Escrow is basically more live than now. I suppose we will see it Q1 for the validators to vote on, I hope. Well, so we will see.
Don't nail anyone on this.
No.
Yeah,
we will see.
I can't make any promises. There's a lot of moving parts involved.
Let's say Q2, Q3, maybe Q4.
Let's say eventually.
Maybe. Who knows? But it will happen in due time. Yeah, so if you like what you see, if you like us talking about all these topics, about smart contracts, smart escrow, smart extensions, and maybe even zero knowledge proofs, even though it's math theory, follow us on X. I will link all the X handles in the description. Like and subscribe, and I hope you learned something new today, and I wish you a lovely day. And until next time, bye-bye.